All right, welcome back. So we're going to pick up on learning some new developments now. Um, Last week we would have finished taking our detour and looking at the forge, housing, and gas inlet piping. So now we move on and pick up on some new developments, squared arounds, which they fall into a category called triangulation developments. So we're going to use Pythagorean theorem a lot here to define true length. So I just want to do this as a setup video for squared arounds, and then we'll get into our next class assignment, which I'm thinking I'm calling class assignment 7, is going to be an actual squared around. With class assignment 6, we did the last round around that was flush to one side. Then we took the detour on the forge body, and now we're looking at the squared around. So I've got a couple I want to go through and just talk about what we're going to see here. On your screen here, you'll see that I've got this squared around. And this one's flanged and ready to go. This is not an assignment we're doing. I've just got a few here that we're going to look through, and I'm going to talk about some of the differences in these. And then we're going to draw, we'll draw one very similar to this. So what I want to point out a few things here. We'll just have a round diameter here that we'll be working with. We'll have a square, and this one is square. Some of these become rectangular where they're longer on one side than the other, but the first one we do will be very similar to this. Just be a nice square base. And then we'll need to know like an elevation, a dimension that between the two. So these become somewhat of a transitional piece, transitioning from something square to round over a given length of measurement. And so then we will just be doing the actual parts in between the flanges here. But what I like about some of these is they show that usually you have to take these somewhere once you get there. So this one just uses, you take the transitional piece, and then they actually just have like a flat bar flange that has a hole pattern in it, matching something, and they just, made their squared around fit into this flat bar flange. And then they've also just made a round flange for the top. So this kind of goes right on the actual squared around, which is a way to do these. And there's other ways too. Sometimes there's a transitional piece between the squared around before I flange it. So I like this one shows a real simple version, which is what we'll start with. This is a couple things to notice here. This is kind of a concentric, or what we maybe I'll label as an equal taper squared around, meaning that the center of the round is directly over the center of the square. So all sides kind of taper equally. So all these sides around this thing are really symmetrical, and it's definitely the easiest type of these we can look at. So the next one is I'm going to look at here is still something that's probably equal tapered that we're looking at here in this, and lighter sheet metal here, probably more of a ducting scenario here. What I'm also showing you is that not all these are just ducting, as we might think that squared arounds are just duct, light duty duct, and spot welded or something. No, not the case. The one that we just looked at above is maybe 1/4 inch plate or something, so it's a heavier piece of duct. It would definitely be welded, not spot welded. This one I like that it shows though that we actually at the top of this where it transitions to round, we put a collar section here, kind of a straight section. And this is probably allowing duct to slip on up to this like shoulder that I'm over here. And then this would be fastened to the round duct that we went to or something. But what I call this like a collar, and this could be a weld-on collar or a formed-on collar, or this could be spot welded on the top of the squared around. So there's a lot of different ways I could do this, but essentially it's just once you go to the round, once you've gone transition to round, which is kind of done via press brake work, you can see that the crease lines here have been press broken to the single point down on the base and up to symmetrical increments around the round to make that thing go round. So, and in here in front of us here, we're looking at a seam here, and I'm going to get to seams in just a minute and the options I have to do seams. It's like anything that we've built so far is I can control my seams, and where I put my seams or sometimes they're weld joints, so I have to be aware of that. But this has a collar on top. and maybe it's been bent, or maybe this is a secondary flange here on the bottom. So I just wanted to show this one. Let's take a look at the next one. So here's more of like a pan. So we think of squared arounds as like duct or whatever, but it can be like a big catch pan under equipment. All kinds of uses for maybe something like this. It's a catch pan. And this is definitely a rectangular round, and it's actually even offset. So it looks to me like this one is not like an equal taper. Looks to in the left of this picture here, it's closer to the edge here than it is over here. So because of its whatever the purpose of it is, it's needed to be an offset taper. And those are, we're going to look at like an equal taper square and an equal taper rectangular. And then as this went on to the next series of lessons, we would look at pushing one of these to offset to an unequal taper. And this one shows like a collar section also, where we're going to the flange here, where the pan and the squared round stops. We've got a short section of collar to transition to round. And I like that this one shows kind of pan side. So where the rectangular pan goes up, they just kind of added a straight section on there. And we can actually develop the squared around section and then just add on, you know, some bent straight sides. So those can be add-on items. Same with the collar, same with this transition to kind of make this into a pan. That can all be added on after I've done the squared around development, given my purpose. So I like that that shows this. Here's, you know, another piece of duct that's been step broke, kind of in halves. I don't have a seam here, but I have a seam here, which leads me to believe there's a seam on the back side here. So this is kind of like this one's been formed in like two pieces, which is, and I told you we're going to talk about these seams in just a minute. I'm going to show you maybe a little 3D version of what's going on there. But yeah, they've actually done all the press brake work and turned this thing in two pieces, kind of. So that's probably the smallest parts I can break it down to, but maybe not always the easiest to fabricate. And it looks like they just go to a single flanged collar on top. There's no straight section of collar here. It looks like I can see some weld going on here, and an angle iron frame or something. So I like to show this one has an angle iron frame that this sets into. So this squared around might have something similar to this. Sorry, this one, where the sides come up straight, and maybe this accepts an angle iron flange. You know, maybe that straight section is able to be flanged, or maybe it's just an unfinished edge here, like for a pan. But you know, I would want to kind of transition that back to straight to put an angle iron flange around it. And here's just this one also shows kind of a two-piece squared around. This is a little bit blurry, but yeah, this is a rectangle around. And what do I got last one? Kind of a large scale squared around, broken in. It's hard to tell on this one too. I definitely am seeing a weld seam closest to me. I'm not seeing any kind of collar. So this is what I like to show about this one is our finished products as we look just will be like this. Like I'm just going to go to kind of the raw edge round. And where I would go from there would be determined by the application. So, and I wanted to show that there's collars I can add to that, or I can put a flange right on that. And so this one just shows, you know, it's almost just sitting on this flat table here. I don't know what the application is, but it kind of shows kind of an unfinished squared around, or maybe it's finished for this application, but this is kind of how ours will be. We won't go to a flange necessarily. We'll just take all points down to where this is square, and then up to where it's round. And so that's kind of the pieces I'm making. And here's another kind of unequal taper that I had drawn up. It's pushed way to one side in this view, and we kind of covered that on this pan one that we looked at earlier. It ended up being an unequal taper too. So anyway, these are a little bit more advanced, and we just want to be able to do concentric equal tapered ones first. And so I think the ones we'll cover this week will be a square and a rectangle. I'm going to pull up just a quick view on AutoCAD of what's going on here. So I'll show you a couple. Like here's just a rough start of how I set up these. This one is actually a rectangular one, so this will be the second one we do. So on your screen right now you're seeing we're going to be working with two views again, only instead of, I think in the last several series of videos, we've been kind of doing front views and right or left side views, mostly right views, right side views and front views. So now I'm going to keep my front view. I need that too, but now I got to have a top view. So these two views are going to talk to each other and get us the information we need to actually pull up true lengths. So I'll mention one more thing back to my PowerPoint and the very first one. What we're looking to define here is all those break line segments that we see in this one. All these break line segments, we kind of need to determine these true lengths, and we don't get that by looking at a top view, and we don't get that by looking at a front view because of the shape of the object. If I'm looking at the top view, there's definitely a lot of distance that those are traveling from the round to the square that I'm not picking up. I have no depth perception when I'm looking at a top view. And when I'm looking at a front view of this, I don't pick up kind of the falling away, the same kind of scenario from the front view where I transition from the square point to something that's round. It's kind of falling away from me in the view. And I'm not picking up accurate lengths in the front views or top views. So I have to interpret both those lengths using a Pythagorean theorem to give me true lengths. And we call these orientation lines. I'm going to go back to my view here. So that's what I'm picking up here. I'm talking about dividing that circle in our standard 12 divisions and then supplying some orientation lines, but we can also call those elements. I have some instructions on one of my screens coming up that will refer to these as elements. They are kind of the orientation lines, and I'm zooming in here. But those are kind of think of these as like break lines, what it's going to take to form those round. I could even put break lines in between these marks. Like, even though I use these to develop the actual true lengths, in reality, this might be too far of a distance to press break that far apart, and I may need to add additional press breaks. I don't really have to modify my part to do that. I can just do that on the press break as long as the part has actually been formed by using true lengths. It'll be close. So I'm going to go over here to another one that we have. It's actually a square. That other one was a rectangle around. This one's going to be a squared around. And what I want to talk about a little bit is, before we start this, I'm going to end this video here talking just about weld seams when we do these, because there's a number of ways I can draw these up. And I'm going to briefly discuss that, and you'll be able to refer back to this video to get a better grip on that once we've drawn a couple of these. But I wanted to put it here rather than in the start of my next video, which is where I'm going to actually draw this first squared around. It is going to be, I think, a 4-inch round to an 8-inch square. I'm not really going to worry about metal thicknesses. I'm just going to draw this to those points. And so what I've done here to kind of show you how I can break this thing up is I've just taken that profile there, and I've drawn the same thing over here. This is 8x4, and then I've got some X's through here and some cross. These all are kind of center lines, and so this doesn't really divide my circle. So for these points that I've established here are not going to be the same points as dividing this by 12 like I'm going to do when I actually draw this. This is just for me to kind of show you how I can break my part up and how maybe I would break this up to form something like this up in my options. So what I've used is I've got myself some reference lines to be able to snap some parts out here, but let me just show you. I'm going to tip this thing in view, and it's going to look let me tip this up here. It's not going to look like a finished part here, but you're going to pick up some of the depth perception in what I've got for my parts here. And there is no thickness to these. I've kind of just done these as like paper patterns, and so I haven't really established any depth. But what I've got going on here is I've just got my same rectangular pattern here in the base with no thickness to it or whatever. That's just kind of the finished size, 8 by 8. What I did is I put my 4-inch circle up here, the elevation of what I'm making, which in this particular part, I think it's 6.5 inches that we're going to draw on the next assignment. So this kind of cylinder shape coming up out of my square is 6.5 inches from the base here, and then it comes up to that. This is the finished part size, which would be a 4-inch round here. This just gives me like a little template to kind of show you how my pieces fit up to this when I make these and what my options are. So I think when I was showing you some of those drawings, some of those actual parts, the pictures of the parts. I was kind of describing like, oh, here's a weld seam here. This part's been made in halves, which was kind of how those were made. And I want to show you my preferred way to make it, which usually stems from running a press brake a little bit and being able to handle the part on the press brake a little easier. And working, and that's my experience working with large, not just small ducting squared arounds, but working with large pan squared arounds and kind of heavy duty 10 gauge 3/16 inch thick material. It gets really hard to handle if I'm making it out of some of these configurations. So here's my preferred way to do it, which is this red group of patterns is what I've kind of developed, and I would need 4 of those to be able to make my squared around with this particular weld seam pattern here. But what it does is, and I'm going to copy this particular part here by its base, and I'm going to show you. So this piece actually ends up being the 8 inches on the square side, and then it matches up there to where it meets my 4-inch round, 6.5 inches tall. So what it does, I'm going to drop this in place now so you can see this and escape from that. So I've just taken that part that I'll show you how to draw that. Not exactly in this 3D model, but I'll show you how to draw the flat pattern for this. And in this particular model, it kind of shows that it's been formed up. This is what I just dropped on here. This is just kind of the center line of my pattern here, this initial line. And the outside edges all become kind of weld seams. So it would take 4 of these going around here to complete this part. And what it would do is it would put a weld seam on this thing that I've got highlighted right here. That would be a weld seam right in the corner. And the advantage of doing this part like this with heavy duty ducting is that all I'm having to all I'm having to like form in the press brake is down to this single point, and I would just have to press brake this round on top, and then I can stack them all together and just weld up this seam. So I prefer this method for ease of handling on a press brake and only having to worry about forming one end one way. So I don't have to worry about making a 90-degree bend of something down here along with forming something round here. So this just comes from a little bit of experience, and there's a few little things that come up when you do that. Like you'll notice if I'm press braking to a single point here and then up to round, and actually what I would do is from the center point of that pattern down to this corner, I would press brake it like half of this pattern down to this one corner, and the other, from center over to here, I would press brake down to this corner. And I would get kind of that press broke look from those pictures that we started with. But essentially from the center down, I would kind of split that in halves around this top here, you know. Half it would go down to one corner, the other half would go down to the other corner. And it would kind of the disadvantage of this is a little bit, it puts a little bit of work on the fabricator because this is going to flare out a little bit. Like when I'm pressing across press brake dies, it's not going to necessarily be on the die until it starts grabbing up in this area. So you'll have this little jog of like area that didn't span across the bottom die in a press brake that'll need to be kind of almost like hand hammered over to make this weld seam. I know that's not going to be super obvious to a lot of you, and it would take a little bit of press brake experience to see what I'm talking about, but that's about the only disadvantage I had to doing this. It does put 4 weld seams in something too, so maybe if somebody was worried about distortion, you know, I have a weld seam in every corner essentially when I do this. So, okay. Now I'm going to look at another option, and that is a quarter of the pattern. So I'm going to just kind of like, maybe I'm just going to back this up till that disappears. Okay, cool. So I took off my red pattern. I'm going to show you a yellow pattern. The funny thing is about this, the yellow pattern is the same pattern. So it's actually the exact same pattern as the red pattern. It would take 4 of them to do this, and it would be like the pattern coming together in the corner. So now I'm going to make like a copy of this. I'm going to stand it up into my all right, stand it up into my part here. So here's my quarter pattern, and it would actually fit in right here. I'll move this around just a little bit. So what it's doing is it's actually turning 90 degrees at the point here, and still kind of spanning the same amount of round up here. So essentially what I have is this seam. Let me just rotate this a little bit. Get off this. This actual seam right here is going to stay straight. All my press brake work on the round from the center line out is going to be press broke down to this single corner. Now, what I have to do as a press brake operator is I have to like turn that part 90 degrees on one corner when it's in its flat position, and I have to make this go round at the same time. So that becomes a little trickier, you know, to get that. I have to, all of these round press brake works have to work to the same corner and turn that thing 90 degrees. So that can be tricky. Sometimes as a press brake operator, when you do that, you end up getting it round on top, but it still isn't turned over 90 degrees, and I have to like move my part in my press brake to just hit it on the square end and turn it 90 without making the round go out of round. So it's, you know, there's ways to get around that. And if I did it like this, I would have actually like 4 weld seams right down the middle of my squared around. So I'd have a weld seam kind of in the middle of the 8-inch square to square to square. I'd have a weld seam going from the middle of that up to the round area if I made it like this. So it's probably the least common way that I would make something, is actually like that. The interesting thing about me of looking at that is that the actual part is the same part. I just press broke it different to do this. And what I can do now is show you one other way. I'm going to actually probably move this around a little bit and get rid of that yellow one off my mold here somewhere. There, it comes away. Okay. So yeah, the other one I'm going to move into place is this blue one. And what I've done with the blue one is it kind of has, it's like a combination of if I turn this to the front, I don't know where there's my orbit function here. I'm going to orbit over. Okay. So the blue pattern that I have now is kind of half patterns of this. And this was what was kind of common in the pictures, but can be hard to press brake also. It's got a lot of pattern in one, and so when I zoom into it, the yellow and the red part are kind of the middle part, and then I've added like a half a pattern more to that. So kind of at the center line of those patterns, the red and the blue, or the red and the yellow, I've taken like and split that in half and kind of added it to my edge. So now I get like one full section of the 8-inch square, and then a 4-inch section, and back up to the round, and I get a 4-inch section on this end. So, and then the round up here on this end ends up being like half of the circumference of the circle. And so when I form that up, it kind of looks like I've got here my blue piece is like formed up here. Let me rotate around this thing a little bit. But yeah, so this one I'm actually press braking. Let me kind of spin around, just kind of give it a view here. I'm press braking from the center lines of these patterns here. This edge is going to stay straight. All the press brake work is going to go to the corner that's turned 90 degrees and up halfway. Yeah, so, and I've got to get my 2 corners to spin 90 degrees, which can be also hard to hold in the press brake, especially if the part is heavy. It can be hard to hold all that in the press brake and get all that to come around, because if I look at this now, I'm going to be press braking from this corner down to this corner in a various number of hits. And then let me rotate this just a little, and then from over this middle point right here where I'm highlighting down to this corner, and get this quarter pattern right here to turn 90, kind of like the yellow pattern, but then still maintain that this turns 90, and then I still have more pattern to do that too over here. So this is the least amount of weld seams, but can be the hardest to hold in a press brake. And I'll kind of, let me like move that into position now on my little pedestal here. I'm just going to, maybe I'll just actually move that one just to show you, but I'll just kind of select all of its parts. I'm going to just select it by the same little center line here. So, but it would actually step onto this squared around platform here and be half of the pattern. So it would only take 2 of those. It would take 2 of those to get all the way around this thing. And the seams would be somewhat in the middle. And this is kind of what you're seeing in those pictures. Kind of a real common way to do these. But I feel like it's a little bit of a pain on your press brake operator. And I totally prefer a couple more weld seams and something easy to handle in the press brake. And these are just a few of the ways that these kind of transitions can be done. There's still drafters that would do these even different. This is just a real standard way that's been done for a lot of time. And if you look online, squared around transitions, you'll see a lot of this, a lot of these very similar shapes that we're doing here, similar patterning that we're doing. But drafters do get progressively creative, and they do some interesting designs when it comes to unfolding a 3D model. And but what we're going to do is just kind of really common ways. I just wanted to show you those. So these really all just relate to weld seams and where I put my weld seams and how hard the pattern is to manipulate. But really it's the same pattern. It's just a quarter pattern, and whether or not I add some 90-degree bends to it that I've got to, and add on more sections of this and simplify the pattern. But really, the interesting thing to me is, from the red pattern that I like to start with, I can pretty much make any of these. They all, I just split them in half and add them to the ends. And so, anyway, this is the initial setup video for squared arounds, and the next video we'll go to will be starting our class assignment 7, which is going to be drawing this, the very first one, which is a 8-inch square to a 4-inch round, and a 6.5-inch elevation, which I think I have the instructions for that here. And so in the next video, 4-inch round, 8-inch square, 6.5 inches tall, equal taper squared around transition. So in the next video, we'll pick up and draw that. So we'll catch you there.